Good evening and welcome to the 2023-2024 Wiegand Memorial Foundation Lecture at the University of Toronto. It's a pleasure to see so many people out on this lovely evening. My name is Alison Keith, and I'm the director of the Jackman Humanities Institute at the University of Toronto, which is pleased and proud to host the lecture. It's my honor and privilege this evening to introduce the proceedings. Before we begin, I wish to acknowledge that we're gathered on unceded land that remains a sacred gathering place for many peoples of Turtle Island, the territory of the Huron-Wendat and Petun First Nation, the Seneca, and most recently, the Mississaugas of the Credit River. I ask you to join me in acknowledging these communities, their elders, both past and present, as well as future generations. The Jackman Humanities Institute acknowledges that it was founded upon exclusions and erasures of many Indigenous peoples, including those on whose land this institution is located. I'm always delighted to host the annual Wiegand Memorial Foundation Lecture, a lecture series established to honor the memory of the late Dr. William Wiegand, an alumnus of Victoria College in the University of Toronto, who won international acclaim for his pioneering work in the science of rubber compounds, and then, as a second act, immersed himself in the study of theology and the classics. At U of T, Dr. Wiegand earned a BSc in chemistry and a master's in physics. Later, he added a Master of Arts in Greek from Columbia University and an honorary doctorate of laws from the University of Toronto. As the breadth of those qualifications suggest, Dr. Wiegand was deeply interested in how scientists and philosophers and theologians approach some of the larger questions confronting humanity today, particularly the issues that arise from a dialogue between science and faith. To honor his memory, Dr. Wiegand's family set up a foundation, which then in turn established this lecture series. Past speakers include such illustrious thinkers as Northrop Frye, Margaret Atwood, Robertson Davies, Sir John Eccles, and Neil deGrasse Tyson. Dr. Wiegand had an unshakable belief in the need for open dialogue amongst science, faith, and spirituality in the modern world, a belief that we in the Faculty of Arts and Science share. It's an honor for the university to be involved in this lecture series. I was saddened to learn earlier this year of the passing of Elaine Wiegand this past December, daughter-in-law of the late Dr. William Wiegand. She passed at the age of 90, and I would like to acknowledge the members of the Wiegand family who are joining us this evening: Derek Wiegand, his son and daughters, Mike Wiegand and his family, and their friends. On behalf of the Faculty of Arts and Sciences, I would like to express our gratitude to Elaine Wiegand, to the Wiegand family, and to the Wiegand Memorial Foundation for the gift that has made this annual lecture possible. Let me also just mention some housekeeping details before I introduce this evening's speaker, Professor John Haynes. I would ask you please to mute your devices before the talk begins. And I just want to let you know that when Professor Haynes has finished, there will be an opportunity for audience members to ask questions. And the Q&A will be moderated by Nolan Sprangers, a doctoral student in the Faculty of Music. After the Q&A, everyone is invited to a reception in the foyer immediately outside this hall, Alumni Hall, at which there will be an opportunity to speak to Professor Haynes informally as well. And so now, without further ado, let me introduce this year's speaker, John Haynes, Professor of Music and Medieval Studies at the University of Toronto. He has published on music of the Middle Ages and its modern reception in a variety of journals, both musicological, from early music history to popular music, and non-musicological, from Romania to Scriptorium. He's the author of 9 books, including Medieval Song and Romance Languages from Cambridge in 2010, and Music and Films on the Middle Ages, Fantasy versus Authenticity from Routledge 2013. He's a contributor, amongst others, to the Cambridge History of Medieval Music and to Film Music, an introduction in 11 takes. He's been making songs since his teens, and in 2017 he published his autobiographical memoir, Missionary Kid, How I Learned to Say Goodbye. Along with his current research into the earliest origins of music, he's also writing an illustrated children's book entitled Deotila and the Moon Lizard. This evening, as you can see, he will speak to us about music before humans. Please join me in welcoming Professor John Haynes.
Thank you very much. Can you hear okay? Yeah? Everyone in the back? Still on. All right. Yeah. Okay? Yeah? Yeah? Is that okay? Just lean into the mic. Yeah. Okay. All right. Well, after that awkward beginning, I'll just kind of lean into the mic and speak, and if you can't hear me in the back, just raise your hand. I have about, I've timed this very carefully because I have a lot of time periods to cover here, so I'm just going to walk through these slides, and then we can talk about them afterwards if you want. There are many people I need to thank this evening, beginning with the Wiegand family and the Wiegand Memorial Foundation for their generous invitation. My thanks also to Kim Yates, Associate Director of the Jackman Humanities Institute, for suggesting the title Music Before Humans. So this was not my idea. I also want to thank the different experts that I have interviewed in the last year and a half, from paleontologists to Assyriologists, one or two of whom you'll hear from at the end. Neither can I forget to thank my teacher and spouse, Dorothy Haynes, whose love of Mother Earth, along with her ecumenical tastes in reading, have brought me to this point. My journey into our topic began, and not that long ago, by the way, with the simple question, how old is music? A related question is, what is music, or rather, how have humans defined music? To answer these questions today, we'll take 5 steps back in time. The first step will be a small one, only 5,000 years. By the time we get to the 5th and final step backwards, we'll be thinking not in thousands of years, but in hundreds of millions of years. Hopefully, by the end, we will have a sense of the deep history of music. With each step, we'll try to widen our limited human horizons to hear as best we can the many animals that came before us, animals who had been making music for hundreds of millions of years before we humans came onto the scene. First, though, one more thanks. I probably would not have thrown myself into this topic with as much commitment in the last year were it not for my dear dog, Tessa. She was the first dog I ever had, which, if you think about it, is a very human way of putting things. Tessa had me as much as I had her. Every day she taught me to listen to the sounds around me, to the birds in the trees, to the wolves in the woods at night. I live a little outside of Toronto. It was only when she died 10 months ago that I realized how much I had learned from her about listening to non-humans. Tessa made me curious to know more about the non-human beginnings of music. And so this presentation is in honor or memory of Tessa, who died on the 1st of May, 2023. all of these slides have been pared down from the original version. About a week and a half ago, I went through all of them and cut out pretty much over half of the material. So we can go, during the question and answer period, we can go to fuller slides that will, if you want to have a question on a particular point. We're going to spend as little time as possible with humans, but we have to begin with humans, so here we go. Let's take our first step back in time to 5,000 years ago when writing first emerged. The idea that all cultures make music, quote unquote, and use the same basic ingredients of rhythm and melody is a peculiar European idea dating back to the last 200 years. That's the tiny instant at the end of the timeline in blue. In fact, most cultures in human history have had no equivalent for this idea of music as a universal human phenomenon. To give just one example, at the far left of the timeline, you have in cuneiform script one of the closest words used by ancient Mesopotamians. This is the word gala, which referred to a priest-singer, which is illustrated in the statue just below it, or that priest-singer song, so it could denote both things. The ancient Mesopotamians did not have a word for music because they didn't need one. Concepts like gala were more important to them. Past the halfway point on the timeline is when the ancestors of the music concept emerged in Greece. For ancient Greeks, however, musike referred to sound as number, more or less, simplifying things. Over the next 2,000 years, other cultures appropriated the Greek musike concept and kept redefining it. Again, I'm abbreviating quite a bit of material, and we can get back to this point later on if you want. Only in the tiny instant, so in the last 200 years roughly, has the idea emerged of music as a kind of universal human language in connection with European capitalism and colonialism and taking over the entire world. Even today, though, music does not mean one thing to all people. For some of us in academia, it's an acoustic phenomenon. For others, music is a cultural or social phenomenon, whatever you want to call it. The most popular or common meaning of music, actually, is something that is purchased and sold, like an LP or a Taylor Swift concert ticket. We are now ready to take our second step back to 50,000 years ago. This is the archaeological record for human music making. The archaeological record for music, or human music rather, begins with instruments made mostly of animal bone, like the bare femur shown at the far left. The holes in this bone were punctured for changing the pitch as the player blew into it. This particular flute, which is presumably the oldest one, is known as the Divje Babe flute, but many others like it survive all throughout this 50,000 year period. In fact, the authenticity of the Divje Babe flute has been questioned, but again, we can talk about that afterwards if you want. The human connection with animal sound making is also clear in art, as shown in the famous example on the far right. This is the Bison Man from the Trois Frères cave in France, showing a human dressed up as a bison and playing either a bow or a nose flute, or neither, it's been debated, but possibly playing a musical instrument. Only at the very end of this 50,000 year period, so during the tiny instant, barely visible on the screen, did humans do away with the animal connection. Nevertheless, it was preserved by indigenous peoples. A good example of this comes from the bird woman figures shown in the middle of the screen from the Thule people, the ancestors of the Inuit. We see a human coming out of a non-human. This is a very beautiful shorthand for evolution, if you want to look at it that way. In recent years, the view of humans as connected to the broader animal world has been getting more attention. Ecologist Paul Shepard, who's probably most famous today for the concept of eco-anxiety, but he wrote about other things as well. Paul Shepard wrote in the 1990s, just before he died, that the ancient Greeks got it wrong when they claimed that Orpheus invented music and then taught it to the animals. It was non-humans, Shepard writes, who gave us humans the gift of music. I should point out that the Canadian, just for some CanCon, Canadian composer R. Murray Schafer pointed out much the same thing, maybe not as elaborately, about 20 years before. We'll get back to R. Murray Schafer. The topic of human music that we've just briefly covered raises the first of 4 biases I will cover tonight. Prejudices that prevent us from thinking clearly about the deep history of music. When you and I think, for example, of the music of indigenous peoples of the Americas, like the Carolinian Secotans, encountered by the English in the 1500s and illustrated in this painting by John White on the left, there's an unconscious bias at work, whether we think so or not. We tend to think of this indigenous music as being simpler or being more primitive than, say, the symphonies of as an example, not quite a random example, of Austrian composer Gustav Mahler, pictured on the right. This is what I'll call the primitive prejudice. Put that in quotation marks if you want, primitive prejudice. By primitive prejudice, I mean that so-called, and I'm quoting an ethnomusicologist named Bruno Nettel, simple cultures with no system of reading and writing of their own. Now, mind you, he was writing in the 50s, but still. So these simple cultures evolved into so-called higher musical cultures. And yet, why should Secotan songs, or Paleolithic flute melodies for that matter, be any less sophisticated than the prestigious, say, Adagietto from Mahler's Fifth Symphony? We may not use the word primitive anymore, it may not be politically correct, but that prejudice persists today subconsciously. Another example of this same prejudice is the recent distinction in biomusicology between human music and non-human musicality, music versus musicality. The implication here, or the idea here, is that musicality, i.e. non-human musicality, is a primitive version or primitive form of human music. That non-human music making, in other words, is more primitive or more basic than human music. As we will now start thinking about non-humans, it is good to be aware of long-standing biases like the primitive prejudice. Okay. If non-humans were here long before us, for how long had they been making music, however we define it? The 65 million year Cenozoic era puts in its proper perspective the human archaeological record. That's in white at the very far right end of the timeline, and human writing, which is even smaller, the black dash at the far right. Early humans, like the Australopithecine Lucy, shown at the bottom right, date from the very end of the Cenozoic, so roughly 3 million years ago, give or take. For most of the 65 million year Cenozoic, humans did not exist. Many other animals did, and they made sounds of all kinds. Not only mammals, but also insects and birds, just to mention these animal classes. The order of parrots, for example, goes back, and the parrot is illustrated on the left, goes back to the early Paleocene epoch, so an era is divided up into smaller chunks called epochs. Shown on the screen here on the left is a rose-ringed parakeet, a species of parrot. Thinking about such a long stretch of time, 65 million years, forces us to consider long-term trends in animal sound production. One of these trends is the influence of one type of animal on another. In this case, influence of birds on primates over the course of the Cenozoic. Birds make music. Most people agree about that. I won't unwrap that problem, but most of us just accept the fact that birds make music. That's okay. It's kind of a weird thing if you think about it. We'll think about bird music a little later on. Most birds lived in trees, and these tree-dwelling birds were around from the very beginning of the Cenozoic. like the parrot illustrated here. So were primates, beginning with Pleistocapus from about 55 million years ago, one of the earliest primates, shown just below the parrot on the screen. For well over 50 million years then, we primates lived in trees and listened to birds. For 50 million years, we took singing lessons from master singers. Only late in the game did Australopithecines like Lucy go to part-time ground dwelling, and the rest is human history, a very short history, as you can see on the timeline. So in case you hadn't noticed, as we expand the time, the original time periods we were looking at, which we hold so precious, the tiny instant of the last 200 and whatever years just shrinks and it will eventually disappear. But not yet. We're still in the Cenozoic. Let's think about another long-term trend of the Cenozoic that relates to music, gigantism. We mammals started out as small rodent-sized creatures like Orgolestes, shown on the left, who came along just before the Cenozoic started. Over the course of the Cenozoic, mammals went from rodent-sized to giants, like the family of Indricotheres, shown in the middle of the screen. Indricotheres were the largest mammals to ever walk the earth. Gigantism continued underwater in the late Cenozoic with whales on the far right. The largest mammal that ever lived, indeed the largest animal that ever lived, period, is the blue whale, which is still around in our own Holocene epoch, shown on the right. This trend of gigantism is directly related to sound production. As mammals got bigger, their vocalizations became louder and lower in pitch, going from ultrasound, really high sounds, to infrasound, really low sounds, neither of which you and I as mammals can hear. For the deep history of music, or the long history of music, this long-term Cenozoic trend is a major development. Ultrasound, so sounds above 20,000 hertz, gave way to sounds below 20 hertz. Early mammals like Orgolestes, essentially an oversized mouse, would have vocalized in a way similar to present-day mice. In recent decades, biologists have shown that present-day mice have sophisticated vocalizations with set motifs and distinctive musical phrases. Of course, these are impossible for us, impossibly high for us humans to hear. It's only thanks to specialized microphones and amplification in the last few decades that biologists have made major advances in our understanding of the complexity of what we can now safely call mouse song. And as I'm going to be referring to different animals, a really good book as a way into this topic, if you're not a biologist specializing in, say, mice vocalizations, is Ed Young's recent bestseller, An Immense World, which covers most of the main topics to think about, including sound. Now, virtually all mammals, beginning with the Cretaceous period Orgolestes, there she is again on the left, blown up, had a feature that is indispensable to most music. I'm talking about our ear. So I'll differentiate as we go along between sound production and sound reception, but of course sound reception is just as important to music as sound production. The mammalian ear evolved specifically for airborne sounds, although we'll think about other types of sounds later on. For now, let's get a sense of the basic makeup of the mammalian airborne sound ear. Our own human ear has the standard 3 parts as illustrated on the screen, the drawing that I made all by myself. Not that great, but there you go. At the far left is the outer ear, made up of the horn-shaped pinna, followed by the tube-like auditory canal. This outer ear carries sounds to the middle ear, which is made up of 3 ossicles, and they're drawn or shown in gray in my image. From left to right, the hammer, the anvil, and the stirrup, or stapes, which we'll return to later on. So remember that little bone there. These 3 tiny bones transmit sound waves to the inner ear on the right, specifically the curlicued cochlea. Remember the cochlea also. We're going to get back to that a little later on. The evolution of the mammalian ear is usually lauded by humans as a supreme achievement in animal history. And it's true. This evolutionary trait has enabled us humans to refine our hearing and grow some pretty big brains. But it has also limited our hearing powers, cutting out a whole swath of low-end and high-end sounds. As Henry Gee has put it in his delightful book, A Very Short History of Life on Earth, or something like that, humans are cloth-eared compared with many other mammals. In other words, we humans are missing out on a whole lot of music or sound produced by other animals. And again, I'd refer you to Ed Young's book, which really gives you good quick sense of that. A fascinating episode in the evolution of the mammalian ear during the Cenozoic is that of the whale, which evolved from land creatures like Pakicetus on the left to present-day humpback whales on the right. It's interesting to me that in the last few days, an item came up in our recent discovery concerning the whale vocal box, vocal production. Thanks to the miracle of hydrophones, underwater microphones, we now know that whales make music that is simply beyond not only beyond our hearing, but beyond our understanding. To cite zoomusicologist Dario Martinelli, the humpback whale is arguably the most musically inventive animal species, and that would include more musically inventive than us. The whale presents us with a long-term trend that Charles Darwin in the late 1800s first identified as reversion. Originally aquatic creatures like the rest of us, whales slowly reverted back to water during the Cenozoic. At first, they were carnivorous hoofed mammals like Pakicetus on the left. These hoofed mammals evolved into water-dwelling amphibians like Basilosaurus in the middle, and eventually to the late Cenozoic whales like the humpback. During this evolution from land to water, the mammalian ear of whales, so originally land creatures, adapted to the new water milieu. The outer ear of whales disappeared, putting the middle ear right up to the skull. To compensate, the bony shell, which protects the middle and inner ear, called the bulla, became bigger and harder to protect the ear. And yet, amazingly, the three-part structure of the original mammalian ear stayed exactly the same in whales, enabling individuals to hear the extraordinary song cycles produced by their fellow whales. And how far back whale song dates is not known. And at a presentation where I'm covering so much time, don't have time, we could spend the entire presentation on whale song because it's such an incredible topic. But moving on. Obviously, there's much more to say about the music of the Cenozoic, but we don't have time for it today. From mouse and whale music to that of insects, birds, and other creatures, this Cenozoic soundscape, to use R. Murray Schafer's term, which he more or less invented, was extraordinarily rich, richer than you and I can imagine. This was non-human music, the large circle on the screen framed in red. Human music, shown in the small circle, with, incidentally, a few other terms for music or music-related terms that I haven't covered earlier, was a late offshoot of this much older non-human music. The different human ideas related to music shown inside the small circle are then a very late human development. Before humans came along at the tail end of the Cenozoic, the great animal orchestra, as Bernie Krause first called it in 2012, had already been performing for tens of millions of years. Influenced by R. Murray Schafer's notion of soundscape, Krause came up with the neologism biophony to designate the total soundscape of a given habitat or biotome. In a given biophony, each animal produces sound in a kind of give and take. Some singing high, others low, each animal taking turns and playing its sonic role in that particular habitat. And Krause spent quite a bit of time recording different habitats in kind of a depressing way before humans came along and maybe cut down a bunch of trees and to hear the difference. And it makes for a little bit of depressing reading, but it's interesting. In the Cenozoic, there were hundreds of millions of habitats across Earth and hundreds of millions of biophonies. These pre-human biophonies of the Cenozoic were the immediate ancestors of human music. As R. Murray Schafer put it nearly half century ago in a rather prescient book called Tuning of the World, all that humans were doing was to echo this first soundscape. The question of music in the Cenozoic raises a second major obstacle to our being able to think clearly about the deep history of music, the language prejudice. And if anybody's, prejudiced towards language, it would be a, published academic like myself. Language is our bread and butter, so. The idea that human language evolved from primitive animal music is in fact very recent, dating back to the tiny instant, actually dating back to the late 1700s and people like Jean-Jacques Rousseau who first promulgated this idea. True, language and its helpmate writing have enabled us humans to make some pretty spectacular things. Thermonuclear bombs, for example. But lately, the presumed superiority of human language has been called into question. A good introduction to this topic is the recent book by Canadian philosopher Kristen Andrews of York University on animal minds. We now know that not only animals, but also plants can remember, self-reflect, and communicate in sophisticated ways. The fact is, except for us humans, no other animal needs to distinguish between language and music, language versus music, or even obsess about the difference. There's only one way of communicating, sound waves that flow through air, water, or ground. Can we adapt the music concept to these recent findings? As I suggested earlier, the music concept is young, and it's also constantly being redefined. So it's okay to give one more definition. In fact, biologists have been doing this quite a bit for the last 20 years or so. A number of researchers in recent years have expanded the definition of music so as to include non-humans. Those will be mostly biologists and not musicologists, by the way. The following definition, which you have on the screen, combines one by archaeologist Ian Morley. It's a very good book, by the way, by Ian Morley on prehistory of music, and a team of psychologists. And here it is. Music is sound communication using pitch and rhythm creatively. Of course, one of the problems from our human point of view is that a definition like this sounds a little bit too much like language, but okay. You can unravel that in the question and answer period at the end, for me. Okay, the question of music in the Cenozoic, all right, so, yes, all right. We are now ready for a fourth and penultimate step back in time, the Mesozoic era, dating back to 252 million years ago. As you can see on my timeline, the Mesozoic, in green, is almost 3 times longer than the Cenozoic era, in brown, on the right. Viewed from the perspective of Mesozoic time, the human Paleolithic period is reduced to a white dash on the far right, and 5,000 years of human writing to an insignificant black spot. Our own precious, tiny instant of the last 200 years is vanished. It's gone. The immense Mesozoic hosted the kind of biophonic variety that is unimaginable to us short-lived humans. Aside from insects, which I haven't even talked about, we'll leave the insects alone, that's a whole major topic, and early mammals, the Mesozoic hosted hundreds of genera of reptiles. They ranged from quadrupeds, like Proratodactylus on the far left, to bipeds, like Forest Racquid on the far right. And by the way, Forest Racquid was featured on the advertisement for this event, in case you missed that. From herbivores like Diplodocus in the middle, to carnivores like Forest Racquid. Forest Racquid was a terror bird. The overall trend in reptilian evolution of the Mesozoic begins with gigantism as we move from cat-sized critters like Proratodactylus to building-sized sauropods like Diplodocus. The trend then reverses, and miniaturization becomes the norm as reptiles shrink and diversify into the class of avians, still thriving today. These trends, although they're kind of general, have major implications for the deep history of music. I realize that some of you will be disappointed at my not playing any sound clips today. The main reason, aside from time, for not doing so for Mesozoic reptiles is a major prejudice that can be summed, this is our third prejudice, can be summed up in one word: dinosaur. It was in the 1800s, so during the tiny instant, that Mesozoic reptiles were assigned a neologism in Greek, the favorite language of the clergyman who founded the discipline of paleontology. Dinosaur is Greek for Deinos sora, the top left, meaning horrible or terrible, whatever your translation of Deinos is, lizard, horrible lizard. The idea of a terrible lizard stuck, beginning with the first exhibitions in London during the 1850s. The image in the middle shows the shop where the Crystal Palace replica, famous Crystal Palace display of dinosaurs in the 1850s, 53 I believe, hosted by Queen Victoria herself. It was a major cultural event. Were made. In the 20th century, the horrible lizard prejudice led to filmed entertainments like the 1933 King Kong, shown on the right, or the 1993 Jurassic Park in the background image. There's a whole kind of subfield, if you will, of dinosaur films which should be taken seriously, and there's a great bibliography which I can recommend for you at the end during the Q&A. The horrible lizard prejudice has resulted in soundtracks with plenty of high-tech screeches and roars. Still today, the horrible lizard remains what it was at its conception in the 1800s, the manifestation of human anxieties about the nightmare of industrialization. I promise not to play any clips, but I will suggest the following one available on YouTube, cited at the bottom left. In this clip, Sarah Tidwell slows down the recording of her pet starling and asks, "Is this what dinosaurs sounded like?" Now, I'm not going to play the clip for you. I think it's best actually to have this stuff in our oral imagination rather than resort to the internet. To the question, what did dinosaurs sound like, there are as many answers as there were species of dinosaurs, which is to say, hundreds. An early insight came in the early 20th century when it was first suggested that the horns of hadrosaurs, like Parasaurolophus on the top left, may have acted as sound resonators. This theory was debunked for the better part of the 20th century and then returned to at the very end of the 20th century. This theory has been confirmed thanks to CT scanning. Related computer technologies since the 1990s have also confirmed that a number of dinosaurs had the extraordinary lung sac system of their modern-day descendants, the birds. This would have given giants like Diplodocus, in the large background image, extraordinary singing power. The pitch range of these vocalizations is one of the great enigmas in the music of the Mesozoic. A third and most recent advance also connects dinosaur physiognomy to that of their avian descendants. This is the middle left circled in yellow. Most bird species have not one but two sets of windpipes, each activated by a complex network of muscles. This is the syrinx, and it's the reason why birds like starlings are able to outsing any human. The fossil evidence for the avian syrinx goes back to the Cenozoic birds like forest racket, in fact, featured in the poster for this event. Recent studies have suggested that the reptile syrinx goes back even further, some 200 million years back to the oldest clade of archosaurs. So it turns out Sarah Tidwell may have a point. One as yet poorly understood aspect of dinosaur sound communication is transmission of sounds via solids rather than air. The idea of singing through solids may seem ridiculous to us humans, but in fact it's ubiquitous in today's animal world. And again, I would refer you to, as kind of a way into this topic, to Ed Young's Immense World. Non-humans, from frogs and moles to elephants and spiders, use sound waves that actually move through solids like bone or skin or ground. More than likely, sound communication through solids was even more common in the Mesozoic. The main type is called we know about, is called bone conduction, or BC. Because of its usefulness to MRIs and hearing aids that matter to us aging baby boomers, research on sound transmission through bone has advanced considerably in recent years. And we now know that a great variety of sounds can be conducted through bone straight to the inner ear. A related type of communication comes courtesy of the dinosaurs' direct ancestors, the crocodiles. This would be the descendants of the archosaurs, the oldest clade of dinosaurs. Like elephants, crocodiles have tiny bumps on their skin called dome pressure receptors, or DPRs, sensory organs that detect vibrations in water and possibly on land. One researcher, this is Daphne Soares, has recently suggested that crocodilian DPRs go back to the reptiles of the early Jurassic period. The topic of Mesozoic sound transmission through solids brings us to our fourth and final prejudice as humans. Like language, it's a big one. Because our mammalian ears are tailor-made for airborne sound, we consider the only musically acceptable sounds to be those transmitted in the air. Paleontologist Phil Center, for example, views music as having begun with the aerial sounds of the Cenozoic, a view that's reprised in an otherwise excellent book by David Haskell called Sounds Wild and Broken. Another good one to read for this topic. The physics of sound, however, tells us a very different story, and here I'm indebted to my U of T colleague, Jason Harlow. In fact, the image on the right is taken from his forthcoming textbook. All sound is a wave-like thing that moves particles in a given medium. A sound wave has amplitude and frequency, as I've tried to illustrate in the A and F in my drawing of a sound wave here. Sound waves are actually at their slowest in air and at their fastest in solids, where particles are closer together, as you can see in Jason's diagram. That is why, for example, elephant rumbles are such effective songs, because they are traveling through the ground rather than the air. And it's worth mentioning that elephant rumbles were actually only heard for the first time in the 1980s. That was not that long ago when researchers realized that these rumbles that they were feeling were actually sounds, and then had to record them and speed them up to be able to bring them up to pitch and to hear these rumbles. Whole world, an immense world, to quote Ed Young. So these rumbles move 20 times faster than airborne sound waves. In water, sound waves move 10 times faster than airborne sound. They also travel much farther. The songs of whales, for example, can travel thousands of miles. The topic of waterborne sound brings us to our last and longest time period, the Paleozoic era, and I will add probably the most neglected one, certainly after the Mesozoic. For lack of time, I'm going to focus on sound reception rather than sound production, although we could talk about the sound production of fishes, for example, modern-day fishes. During their 275 million year run as the dominant animal class of the oceans, trilobites, on top left dark blue row, diversified in over 230 families and some 15,000 species. I'll let that one sink in for a second. For communication underwater, trilobites relied on tiny sensory hairs that covered their bodies, as shown in the Devonian specimen here on the screen, top left. Detecting waves in water via sensory hairs led to a major development in the Paleozoic, the inner ear of fishes. Two types of fishes evolved in the Paleozoic. First came the jawless fishes, which survive today as lampreys and hagfishes. That's the second blue row on the screen. An early jawless fish is Haequictis, the little gray guy on the left. The second major fish type in the Paleozoic were jawed fishes. This is the third row, the bottom one in light blue. Miscanthus, this is the bottom left drawing, was an early jawed fish. From the clade of jawed fishes evolved bony fishes, and from these bony fishes descended two major clades. They're numbered in the third row. One, the teleosts, from whom would descend all extant fishes, and two, the tetrapods, from whom descended our own human species. In other words, what happened to fishes during the Paleozoic is of great interest to us humans, or at least it should be. And one of the things that happened to bony fishes during the Paleozoic was the evolution of the inner ear. This relates to you and me, since every sound we hear, including the sound of my voice right now, is processed through in each and every one of you through tiny vibrating hairs in liquid, the cochlea, pictured on the bottom right of the screen. or that's actually a bad drawing, but that's all I could find. It's a pink tube on the right. For each sound that we hear, the tiny hairs in our cochlea vibrate in their liquid, hairs in liquid, and transmit a sound message to our brain. Here is how it evolved in a very short sentence or so. Near the beginning of the Paleozoic, on the far left, jawless fishes like Mescanthus, again pictured on the top left, developed an inner ear, rather otic capsule it is called, the round spot on the fish's head. So pictured below is the fish ear with the saccule in the very bottom. The saccule is a part that's used for hearing. The upper part is used for balance, at least in our version. The inner ear evolved in connection with a lateral line system of sensory hairs on the bodies of fishes like Mescanthus. So the dots that I've pictured on his body, their body, is the lateral line going out of the otic capsule or inner ear. In a separate but related development, jawed fishes also developed various jaw bones. One of these jaw bones was a bracing strut that turned into a sound conductor for early creatures like Seymoria. That's the lizard-looking guy in the middle. An early tetrapod, Seymoria, had all the ingredients of the reptilian ear later found in dinosaurs. From left to right, in the middle drawing that you have below of a reptilian ear, a flat eardrum, so there's no outer ear, a sound-conducting bone. It's actually several sound-conducting bones. The longest one there is, in fact, the stirrup, the stapes. And finally, an inner ear with a slightly curled cochlea, not quite as curly as yours and mine, but getting there. That early tetrapod cochlea became the curly cochlea of mammals. And that's the broken arrow on the right. Or not, it's not broken, actually. It's the brown arrow on the right. And the stirrup shrank to become one of our middle ear bones. That's the blue arrow. This whole transition from aquatic to airborne sound ear is the central episode in the deep history of music. Next to it, Beethoven's symphonies are insignificant playtime scribbles. Sound received by tiny sensory hairs floating in water. This has been the most consistent mode of communication in all of animal life. From our current Cenozoic era all the way back to the Paleozoic 542 million years ago, animals have communicated thanks to tiny hairs floating in liquid, the cochlea in our case. We mammals will never know, of course, what it was like for a Paleozoic marine animal to experience sound waves in water. As Canadian paleontologist Tatsuto Mayushita recently said to me, we humans are stuck with a very anthropocentric way of thinking. One big difference between us, mammals or humans, and our Paleozoic ancestors is that they detected waves not just with their inner ears, but with their entire body. John Ryan, a specialist in oceanographic sound, related to me a story about an underwater photographer friend of his who had spotted a sperm whale. The photographer let the whale approach, and as it did, it started interrogating him with sound. As if, and I'm quoting John Ryan here, as if he was asking him a question. Every cell in his body vibrated with the intensity of the sound. Underwater sound is not just an ear thing, it's an experience of the whole body, receiving and emitting sound waves. If we had to redefine music for the Paleozoic, we might borrow the definition given by Siddhartha Mukherjee in his bestseller, The Song of the Cell. And so on the screen, he uses the word song, but we could just substitute music. Music is a series of messages sent out from one being to another to signal interconnectedness and cooperativity. Mukherjee's Song of the Cell is a book about the earliest form of life on Earth, one that predates the Paleozoic era by hundreds of millions of years, microbial cells. These earliest life cells on Earth 4 billion years ago had tiny hairs called cilia and flagella. Just like the tiny hair cells of our cochlea, these hairs were the conduit for messages sent out from one being to another. They were the earliest music on Earth. Or were they? If we had time today, I would take yet one more leap back in time, back to the first orbits of our planets around the sun that the ancient Greeks and medieval Latins called the music of the spheres, or the harmony of the spheres, but there isn't time. When I think of our young planet, 4.5 billion years ago, I think of Tessa, my dearly departed dog, of Tessa when she was very young. I think of how long ago that was, not hundreds of thousands of years ago, not hundreds of millions of years ago, but 13 years ago. And I am grateful. I am grateful that you and I could spend this time together thinking about what music might have been before humans. And I want to thank you for being here today with me to think about this very unusual topic.
Thank you, John, for such a fascinating talk. My name is Nolan Sprangers. I'm a PhD student at the Faculty of Music and in Environmental Studies as well. And I'll be leading this final portion of our time here this evening. So you will have a chance to ask any questions to Professor Haynes. Lisa's just setting up some microphones in the middle row, so we've got one towards the back, and we'll have one at the front here as well. But just while we're getting set up, maybe I'll start us off with a question. So John, you mentioned that in this tiny instant that you talk about of music that we're in now, we're getting further and further away from the non-human world. Yet our sheet music is printed on plants, instruments are made with woods from different trees, animal skin for leathers, gut strings. So do you see any sort of compatibility between this much deeper history and our conception of music in this tiny instant now?
Yeah. Thanks. That's a great question. Thank you very much. Well, I mean, needless to say, I think part of my throwing myself into this topic, aside from Tessa, has to do with all of our collective anxiety, eco-anxiety, if you want to call it that, about, what has happened to our connection to earlier non-humans. I don't know how to answer that question. I think probably all of us can kind of feel there's something that we've lost. The question at some point, of course, as one considers the deep history of pretty much anything, is when did things go wrong, right? What's his name? The author of *Sapiens*, 2014 book. Harari, there we go. Yes, Harari. This is probably an early book where, if you look at the opening page of Harari's *Sapiens* from 2014, there's this chronology that makes immediately clear that as soon as humans show up, that's pretty much when things go wrong, right? So the question that that's the answer as of the 2010s. Paul Shepard famously in the 1980s was suggesting that things went wrong in the Neolithic. That was kind of his theory, and so. Before that, probably, people would say European capitalism, the last 500 years. As far as how that relates to our, moving further and further away from that animal connection, I don't know. But I suppose, the closer we can get back somehow, better things will be.
Yeah, thank you. All right, I'd like to open it up to the rest of the audience. So if you have a question, feel free to come towards whichever microphone is closest.
My cat of many years ago had a real appreciation of music. And what happened was my husband went on a trip to Ukraine. He brought back as a souvenir a primitive little shepherd's flute with a few holes in it. And my daughter had a friend visit, picked it up off the table. She was a real flutist, and she picked it up and played a few bars. And my cat stopped what he was doing and listened with both ears. And then she stopped playing and he said, meow, which means, and I said, I think the cat wants more. So she played a bit more. She stopped and he said, meow again. And she gave him a second encore. And then I guess he was satisfied and went back to what he was doing. And I think he really liked the music. Now, was your dog the same?
Yeah, that's that's a great anecdote. My dog really didn't appreciate flute music. I think probably I tried to play the recorder once or twice, and that was the end of that. Yeah, that's interesting. I mean, we're one of the other things that's happened in the last few years, sort of in the last 10 years since Harari wrote his mind-bending *Sapiens*, is these animal videos, right? That so many of us, well, some of us, watch. We can now hear so many, the sounds of so many different animals and be exposed to every person kind of becomes their own biologist, if you will, in a way that was not possible certainly 20 years ago before the internet. So, yeah, thanks for that story.
The cat was absolutely quiet while she was playing. And then she stopped. He says, yeah.
Do we know if animals use sound or music purely to entertain themselves?
Yeah, that's a great question. I thought I had a slide. I don't have a slide on that, no. Some of the other slides that I have, let me just quit here, see if I can find that. But so the topic of animal play is probably the best place to go for thinking about that, and in connection with music would be Martinelli's, let me pull up the slide, Martinelli's Zoomusicology from 2009. Dario Martinelli was one of the first musicologists, sort of trained musicologist, trained semiotician, to think about animals seriously, to take that topic seriously. And in this book, he talks about play because, of course, animal play is well studied by biologists. And Martinelli, in fact, suggests that play, probably in terms of animal evolution, was one of the earliest manifestations of kind of animal, non-human musicality. That's a relatively early insight in terms of, biomusicology, zoomusicology. Which is probably no older than the early 1990s, when the term biomusicology was coined, and then I think it was Martinelli, I believe, in the early 2000s, who came up with this word zoomusicology. No, it wasn't Martinelli, but he was the one who made it famous. It was actually a French organist, French composer. The last name is Mache in the 1980s, so he was the first person to think about zoomusicology. He came up with that word. But before that, really the idea of taking animal music as seriously, non-human music as seriously as human music was really not happening, certainly within academia. But yes, to get back to your question, play, the whole topic of animal play and non-human play is really closely related to the question about the evolution of music.
I have a meandering question, which unfortunately I think is only applicable to the last 500 years, so it's not necessarily the nature of your talk. However, as you mentioned, when humans came along and ruined everything, I'm thinking about, before that and what perhaps has been lost. And I would love to know what the human ear heard 10,000 years ago versus what we hear now. And as we know, we can't see a lot of the light spectrum, and we can't hear a lot of the sound spectrum. But to sort of take things in reverse, and to mention stupid YouTube, there's a parrot, which you had in slide 1 or 2, I think. There's a guy who plays guitar, and his parrot sings along in tune. So our stupid, 8-tone, 12-tone, whatever scale has now been imposed on this bird that probably has a range, that's incredible. And then the other thing that occurs to me, really meandering, is that because I grew up here, I don't hear quarter tones very well. And I've tried, and eventually in Arabic music or what have you, wherever, from at least a third of the planet, if not more, and they can hear that. So there's a cultural thing factored in as well. And I'm wondering if there's any information on increments, I'm sure, much smaller than a quarter tone that would be perceivable by things more advanced than us. There's my mess of a question.
Yeah. No, there's no answer for it. I think but your point, one of your points was that animals have changed, with us. I mean, all you have to do is think about the telegraph wires. I think there's a sentence in Darwin's Descent of Man where he's writing in the 1870s, and he mentions the telegraph wires and that birds, so many birds have perished by hitting these wires, which they were not used to seeing before, say, 1850, right? And that eventually over time, seeing the body, I'm forgetting the exact phrasing, but eventually over time, seeing the bodies of their fallen comrades, as he puts it, they finally realized, okay, we need to adapt to these. The question of how much animals, say, in the last 200 years have adapted to us, like you're talking about these videos, is a really good one. And that's the kind of work that, still waits to be done. I mean, there are so many possible topics in terms of PhD theses. You probably already have yours, but that are kind of begging to be done. Yeah.
Hello. Firstly, I'd like to thank you for your amazing presentation, so thank you very much.
Thank you.
So you mentioned that music is a form of communication. So I was wondering if there's any evidence in the history of non-humans of creating music kind of recreationally, different kind of melodies as we know it, as opposed to just solely for a communication purpose.
Yeah. So basically where the research is, the bulk of the research, which is why I was interested in more in paleontology, bulk of the research now, and that's getting, the press and the news and all that, is with present day animals, right? People like Tecumseh Fitch or other biologists who are like this whale story that came out in the last few days, right? Dealing with present-day animals, and the theories are really working mostly, if not exclusively, with communication, right? But yeah, you're again raising the question of play that Dario Martinelli raises in his zoomusicology book. I think that's a big question. Like, that's an important question to ask. Were animals in previous times, whenever, playing with sound without any particular goal in mind? Probably. Whether we can imagine, say, a dinosaur playing with sound without the need for communication being there, that's an interesting question, I think.
Do you think that human human influence has influenced animals or non-humans today in their kind of music perception?
Of course.
Production.
I mean, it's hard for us now to find, a spot on Earth which has not been, polluted by humans. To find animals that are living without having been exposed to human beings. Now, this is practically impossible. So, yeah, I mean, I think that's...
Sorry, one last question.
Yeah, sure.
How do you think that will then affect the future of non-human kind of communication?
Well, yeah. So now you're coming to the whole topic of anxiety, right? I mean, I have to say that part of my my thirst for knowledge about this topic is driven by the kind of the eco-anxiety that is in our collective unconscious, whether we admit it or not. I want to know the answers to these questions, even as we can see, every year, every month, humans further encroaching. To take just the aquatic, the seas, the news is bad. It's just very bad every day. It gets worse. So yes, one wants to kind of capture these things, such as whale songs, before, ships start completely obliterating the songs of these amazing creatures. Well, the irony, of course, is that all of these discoveries have been made sort of in tandem with human encroachment. I mean, if you look at, this is one of the things I explored for the book project of this. If you look at the let's say the discovery of fish ears, that basically started in the early 20th century. Before that time, scientists were divided at best, didn't think that fish had ears. But as hydrophones became possible, submarines, the World War II was a watershed moment in terms of hydrophones and underwater research. But with that came major destruction of water habitats. One need think only of the testing for thermonuclear bombs in the 1950s. That destroyed entire islands, and all we see is a plume in the sky, but stuff was happening underwater, which was not that great. So, yeah, to answer your question, I don't know. Of course, I probably would tend to be a little bit less optimistic. I hope you're more optimistic than me.
Thank you very much.
Thank you.
Thank you for a fascinating lecture.
Thank you.
I have so my question is how, if at all, this story of music and sound that you've been telling sort of overlaps with a story of dance and bodily dance and bodily movement.
Yes. Oh.
So I know that birds will do these very elaborate kind of dances for one another, and they've been mapped out and by biologists looking at their evolution, and I think that they're coordinated with sound as well. So, I mean, how deep does that sort of connection, go between coordinated bodily movement, rhythm, and sound and music?
Yeah. So this has been explored by, at least as early as Dario Martinelli. Again, I keep referring to this book. It's a good book. It's called Zoomusicology or something like that, from 2009. We only have a copy on campus, just so you know. So. But he explores that a little bit, the dances, notably of certain birds, like cranes, most famously. The question then for biologists or evolutionary biologists is how far back does this behavior go in, say, cranes? A variety of cranes, for example, have elaborate dances and so on. For the most part, biomusicologists have kept to present-day animals. So that's interesting, but it would be even more interesting, at least I feel, to at least conjecture how far back these behaviors go. Because, of course, humans, again, we're watching or listening to the earlier soundscape, and more than likely, I think you're right, they were listening and watching to this music and movement, this dancing. It's intriguing, isn't it, to think about. I feel like one or two other people have written about this, maybe Bernie Krause a little bit, but Martinelli in this book that I mentioned has as well. And of course, there is recent research by biomusicologists. Honing is his last name here. Let me find this reference on my loaded slide. Here somewhere. On the bottom left, I originally had bibliographic references, but this just crowded out the slide. So, on the bottom left here, you have just while we're looking at it, Kristen Andrews, How to Study Animal Minds. This is a really good introduction to the kind of biological issues I was talking about. Here is Paul Shepard's book, The Others. The Gift of Music is a chapter in this book. This book was published the year he died, I believe. A really great book. And there's also Krause's Great Animal Orchestra. But there's Martinelli's books. Actually, it's not entitled Zoomusicology. That may be in the title. Martinelli's Of Birds, Whales, and Other Musicians. This is a great introduction to the topic. But that's not the book I'm looking for, and I'm going to get to it here in a moment. Here it is. Honing is the last name. The Evolving Animal Orchestra. Oddly enough, this is 7 years after Krause's book, but he doesn't give credit. He doesn't cite Krause anywhere. This book was translated from the Dutch, so maybe he could be forgiven. But this would be typical of the trend in biomusicology nowadays, which is to focus almost exclusively on present-day animals. Essentially, the idea is, in fact, Honing states this in this book, a 2019 book, that, well, there's no record of sound in the fossil evidence, so never mind that. There's nothing to say, nothing to look at here. Paleontologists have been saying something different. In the last 30 years, at least, have been uncovering all kinds of amazing stuff about the sound world of ancient animals, including everyone's favorite, dinosaurs. So, yeah.
Thank you.
Thank you.
All right, if there aren't any other questions, I think we will wrap this portion up there. So thank you again, John, for a really interesting talk. I do find it interesting. We all have these stories about a pet cat or a video of a bird we've seen. We see and hear these things happening around us, but there's still so much to learn about it. So just a couple things to wrap up here. Thank you again to the Wiegand family for sponsoring this event and making it possible. And we will be having a reception in the lobby just after, so if you'd like to continue conversation informally, please feel free to do so out there, along with some food. And very last thing here, Allison Keith will be presenting a gift.
Thank you very much. Thank you very much. Thank you.